Number 6 is about a football being kicked from the ground. So we know h naught equals 0. At an angle 55 degrees, so theta equals 55 degrees, with an initial velocity of 50 feet per second, so v naught is 50 feet per second, and that means gravity is in feet, so gravity is 32 if we need that. So first thing it asks is, give me the maximum height reached by the projectile. All right, this is one of those ones where you have a projectile being shot up in the air and comes back down. And if this is the time, and this is the height, or y, at time 0, it's y is 0. And then at sometime out here in the future, height is also 0. So we use that fact, and we use our y equation to find the time. And remember, we want the time when it's at the maximum height. And isn't that the vertex, the x coordinate of the vertex? And so we remember that we find the x coordinate of the vertex. So we say v of x is the opposite of b over 2a. And instead of x, it's t, time. So the vertex at time t would be negative b over 2a. So we use our y equation. Y equals, let's write the whole thing down so you remember it. It would be t v naught sine theta minus 1/2 gt squared plus h naught. So let's get it in, substitute in our numbers, and then get it in quadratic form, right? Standard quadratic form to give our a's and b's. So we would have y equals t. We don't know t. V naught is 50 sine of 55 degrees minus 16, because we're using half of 32, t squared plus 0. So putting it in standard form, it's y equals negative 16 t squared plus 50 times sine of 55 degrees t. All right, and so now the opposite of b would be negative 50 sine 55 degrees over 2a, which is 2 times negative 16. And so this is the v at t, so the time would be, if you punch that into your calculator, you get you get 1.28. And that is in meters per second, so this would be in seconds. You were given velocity in meters per second, so it's 1.28 seconds. Now that's just the time. It's this point we want right here at this time. So t is equal to 1.28, but what is y? So we go back to our y equation and we substitute that t in. So we would have y, that's what we want, is negative 16, and then 1.28, that's time squared, plus 50 sine 55 degrees times 1.28. Now, if you punch that into your calculator, you get 26.21 feet. So that is the maximum height reached by the projectile. So that was old part A. Let's move on to part B. Okay, part B says find the horizontal distance, that's our x, traveled by the projectile when it reached its maximum height. So when, what time was its maximum height? It was at t equals 1.8, t equals 1.28. So let's remind ourselves of our formula. We would use the x because we want horizontal distance, and x is equal to t v naught cosine theta. Now, if we remember from the initial problem, v naught was 50 and the angle was 55, so we would have 1.28 times 50 times cosine of 55 degrees. So if you punch that into your calculator, 1.28 times 50 times the cosine of 55, you should get 36.71, and we were using feet, so feet. So that's how far it had gone horizontally when it was at its height. All right, and there is a part C. Okay, part C talks about the ball being kicked towards a 10-foot goalpost. Will the ball pass over the post? If not, how much higher will the ball need to be? Well, they didn't tell us how far away the goalpost does, so you cannot do part C. You would need more information. So you can just skip part C. Okay, so that was your homework.